Hi, I'm Ed Allen. I'm the park historian, and today we're going to talk about the origin of gold. Now, if you've been up here in the foothills of the Sierras for any time, you realize that there's places where there's gold and there's places where there's no gold. So, how did that all come about? Well, when the Earth was formed 4.5 billion years ago, gold was disseminated evenly in the surface of the Earth at 5 parts per billion. To give you an idea what that is, if you had a grain of sand, a line of sand grains from Placerville to Denver, Colorado, you'd have about 5 billion particles, or I'm sorry, a billion particles, and 5 of those would be gold. So obviously we need some kind of a geologic mechanism to concentrate gold in a particular area, like the foothills of the Sierras. And by the way, gold in seawater is 25 to 35 parts per billion. So we know of a couple of ways that gold can be concentrated geologically. The way that we're interested in is something called black smokers. So when the tectonic plates on the Earth's surface collide, or when they pull apart, we have the formation of what we call black smokers. And basically what's occurring is the ocean floor is basalt all over the world, basalt. And it has a specific gravity of 2.9 to 3. Most of the Earth's surface is made out of silica materials. They have a specific gravity of 2.7 to 2.8. And so the continents, which are mostly silica, literally float on top of the basalt, which is heavier. So when these plates collide, or when they pull apart, cracks and fissures appear in the basalt. Water circulates very deeply into the earth, and by the way, the basalt is very porous. And the water goes down to the point where it gets hot. It gets hot to the point of maybe 800-900 degrees Fahrenheit, and when that water comes back out, it is mineralized. The hot water will leach minerals out of the basalt. And the two that we're mostly interested in are sulfides and chlorides. Both of these have the ability to attach themselves to free-floating particles of gold in the water. This is micron gold. So we call it a black smoker because the material coming out of that fissure is so mineralized it's black. And it's creating a plume above it, a hot water plume. And as the particles, sulfides and chlorides, attach themselves to particles of gold, eventually they have enough mass to precipitate or fall to the ocean floor. Now here, we didn't have sea floor spreading, we had a subduction zone going on. The Pacific plate had collided with the North American plate, and the North American plate is going over the top of the Pacific plate. So these cracks and fissures appear in both the North American and the Pacific plate. The black smokers come up from the basalt, start this plume effect, start gathering gold literally, and when it precipitates the ocean floor, since we're in a subduction zone, it's slowly, over millions of years, going under the North American plate. There's cracks and fissures in the North American plate also. So around here, this happened just offshore, and we're talking about Jurassic time. So we're talking about 132 to 170 million years ago. So we're in a subduction zone. So this calcium and carbon, gold, is all being pulled down underneath the North American plate. And at depth and pressure, the calcium and carbon are going to react, forming calcium carbonate. That's the mechanism that pushes the gold up into the North American cracks and fissures. It's just like shaking up a can of soda pop and popping the top. So silica is present, and it's in a liquid state at this point. And that liquid, that viscous fluid, is bringing gold and other metals up into the cracks and fissures of the North American plate where it's depositing them. So that went on between 132 and 170 million years ago, that gold deposition. And then that all changed. That era was over with. The San Andreas Fault formed basically, so that now we are slipping the two plates by one another. And the subduction zone's still around, but it's moved up to the coast of Oregon. And if you look at a map today of the earthquakes that happened in California and Nevada, you'll see that right off of the coastline at Eureka there's a fault that runs right out into the ocean, straight out. And there's earthquakes there quite often. In fact, there's been some really, really big earthquakes up there. That's that separation point. That's where the San Andreas fault stops and the subduction zone begins. So the next era that we get, the San Joaquin Valley and Sacramento Valley start to sink and fill with sediments. There's 50,000 feet of sediments out there in some points in the valley. And so it bows down, and the Sierra Nevada mountains start to rise. We call that orogeny, or mountain building. And as they rose, the gold in quartz was exposed through weathering. So when James Marshall discovered gold here, the gold had been weathering out for over 100 million years. And that's why there were just massive quantities of gold in the creeks and rivers. That's called placer gold. Placer is an ancient Spanish term that means sandbank. We find that gold in the sandbanks along the creeks and rivers. That distinguishes it from hard rock or lode gold, which is basically gold in quartz. And all over the world, these subduction zones at various times have occurred. And so 90% of the gold found in the world is in quartz. And I'm going to give you some samples of that, or show you some samples. So this is placer gold, and this piece by my thumb, this is a nugget, and it was found Mother's Day 9 years ago right here in the park. That nugget means absence of rock. People think it means all gold, and that's not true. You can never find pure gold in nature. It doesn't exist. Gold is always an alloy. Alloy meaning two or more metals combined. So this piece is 94% gold and 6% silver. The other piece here isn't a nugget. It's got quartz down inside of it, and because of that, it's gold in quartz, not a nugget. That piece is from the Yuba River. It's 85% gold, and the rest is silver and copper. So the amount of gold in the nuggets and so forth that we find vary tremendously. Sometimes you can find gold and silver combined 50-50. That's called electrum. Doesn't even look like gold, looks like silver. So this is gold from the creeks and rivers. And this is gold from a gold mine. This is a vein of gold running through a piece of quartz. So this is going to have to be crushed in our stamp mill, and we'll be talking about that later on. We'll crush it down to a very fine particle size and extract the gold using mercury. And of course we did all of this because we used gold in the old days as money. So if you look at your geologic map, you'll see that the green on the map in the legend is metasediments, chiefly Mariposa Formation, slate, greywacke, etc. So I told you that this gold came from seawater and from the ocean. And sure enough, greywacke is sea bottom mud that's been metamorphosed. In other words, heat and pressure have turned the rock from a sedimentary rock to a metamorphic rock, much harder rock. So the gold that we find here in this area is in the Mariposa slate. So that's the green area of your map, and if you'll notice those red dots on the map, those are historic gold mines. And you'll see that most of them are right in that Mariposa slate formation. And you'll notice also that the town of Coloma is not in that area. The Mariposa slate here in this area is on the other side of Mount Murphy, and it actually goes north of Auburn, which is on your map, down through Georgetown and right through Placerville. And that's why there were gold mines literally in downtown Placerville. So all of the gold that they found here in Coloma was washed down. It was all placer gold.